Hi everyone, welcome to my channel Math with Miss Sabrine. We will start topic 1.4 of IB Math AASL today. This topic is all about financial applications of geometric sequences and series that involves the concept of compound interest and annual depreciation. I will start by explaining the difference between compound and simple interest first. Let's say you are very rich and you have $20,000. You don't know what to do with it, so you decide to split the money and invest it in two different banks. Let me name this Bank A and this one Bank B. You go to Bank A and you deposit $10,000 with a simple interest rate of 5% for 5 years. You go to this bank, you also deposit the same amount of money. Now the money that you deposit in the bank, that's called your principal amount. For this bank, you have they will apply a compound interest rate of 5% and you will also keep the money for 5 years. So it's the same things for Bank A and Bank B. The only difference is this bank will follow simple interest and this bank will follow compound interest. Now let's have a look at what will happen in these two different types of bank. Now in the first year, you will get an interest rate of 5% for this bank. So 5% of 10,000, 5% of 10,000 will give you $500. This is your interest rate for the first year. Now the total amount would be you had 10,000 already, and on top of that you got $500. So in total you are going to have $10,500. Now for this bank, it's the same thing. You will also get an interest rate of 5%. 5% of 10,000, actually it's the same thing. 5% of 10,000, you will also get $500. So the total amount is going to be the same. Now remember that this is the amount of money that you will receive at the end of the first year. So let me just write it down. At the end of the first year. Okay, so you have the same amount of money in the first year. Now let's see what happens in the second year. So I start the second year. For Bank A, the interest rate would be the same next year. That is 5% on the principal amount. This is the main difference between simple interest and compound interest. For simple interest, this interest rate is always on the principal amount. In this case, it's $10,000. So you are also going to get the same amount of money in this year, 5% of 10,000. If you don't know how to calculate that, 5% is 5 over 100. That is 0.05, and you multiply it with by 10,000. So you will also get $500. The total amount would be different because you already had $10,500. So you are going to add this $500 with this $10,500. So in total, you are going to have $11,000. If you look at the terms, first of all, you had 10,000. Then at the end of the first year, you had 10,500. At the end of the second year, you had 11,500. You can clearly see that the numbers are increasing by a constant amount, by 500. That means this is an example of arithmetic series. But this is the amount of money that you are going to get at the end of the first year. This is the amount of money that you will get at the end of the second year. That means if you want to, this is your first term, this is your second term, this is your third term. So if you find the second term, it actually means the amount of money that you are going to get at the end of the first year. Okay, let's keep it like that. Now move to Bank B. Let's see what happens if what happens in compound interest. Here, the difference is the 5%, the interest rate that you had, it's going to be on the total amount, not on the principal anymore. That is the main difference between simple interest rate and compound interest rate. So that means the 5% is going to be on 10,500. So 0.05 multiplied by 10,500 will give me $525. So the total amount would be $10,500 plus 525. This is the main difference. So you are going to get 11,025. This is what you will get at the end of the second year. Now let's look at all the terms for Bank B. You had $10,000 first. So the year after that, you got, what did you get? $10,500 as well. But at the end of the second year, you have 11,025. Now, what kind of series is this? If you look at this, 10,500, and if you divide it by 10,000, you will get 1.05. If you divide 11,025 by 10,000, you will also get 1.05. This series has a common ratio, which is 1.05. That means this is an example of geometric series. So compound interest follows geometric series, and simple interest rate follows arithmetic series. Okay, so this is the main difference. Now the question is, you had the money in these banks for 5 years, so we have to find the amount of money at the end of 5 years to compare the difference, the amount of money between these two banks. Okay, so let's see. Like I told you before, this is the amount of money, this is the principal value, but this is not your sorry, so this is your principal amount, and this term is what you will get at the end of the first year. That means this is your second term. If you want to find the amount of money in the 5th year, you have to find the 6th term. Take some time to understand why I said that. So the 6th term of this, I'm just going to follow arithmetic series, which is U1. The first term is 10,000 plus 6 minus 1 multiplied by $500. This will give me 12500. So this is the amount of money that you are going to get at the end of 5 years. Now let's look at this. Because we know that this is following a geometric series, it also follows the same thing. This is your first term, this is your second term, but this is the amount that you got at the end of the first year. So if you want to find the money after 5 years, you're going to find the 6th term of this geometric series. I'm just going to use the formula for geometric series. It's going to be the principal amount, U1, the first term, times the common ratio, which is 1.05, to the power of 6 minus 1. If you put it in the calculator, it will give you 12762.82. So this is the amount of money that you are going to get for Bank B at the end of 5 years. Now you don't have to do all of this all the time. If you know the bank is following a simple interest rate, you can also use this formula straight away. A equals to P times 1 plus NR. This formula is not given in the formula booklet for IB Math AASL. So you need to remember it if you want to use it. Otherwise, you can just use this formula straight away. So this equals to, I'm just going to show you that this gives the same answer. 1 plus N is the number of years. In this case, I'm just going to use 5 straight away. 5 times the interest rate is 0.05. This will give me $12,500. See, the same. So it doesn't matter if you use this one or this one, but if you use this one, you need to memorize the formula. Now for geometric series, there is also another formula, but this will be given in the formula booklet, so you don't really need to memorize it. I'm just going to show you. FV equals to PV 1 plus R. I'm just using the format that's given in the formula booklet, to the power of K and N. Now let's look at the symbols. FV means future value. That means the total amount that you are going to get after a certain period of time. PV is the principal value. It's the amount that you deposit in the bank. 1 is 1. R is the rate of interest. And K is the number of compounding periods per year. That means how many times you compound the money. In this case, it's just 1, so you don't really need to worry about it. I'll show you more examples in the next video with questions based on this compounding periods only. Then this N is the number of times. Now PV is the principal amount, which is 10,000. In bracket, it's going to be 1 plus the compound interest. The interest rate is 5 over 100. This K is just 1, so there is really no point in writing it, but I'm still going to write it. K is 1 as well, and number of years is 5. If you put it in the calculator, it's just nothing but this. See, 10,000, 1 plus 5 over 100 will also give you 1.05 to the power of 1 times 5 and 6 minus 1. It's actually the same thing. So you are going to get 12762.82 as well. Now let's look at the difference between compound interest and simple interest. You will get a constant amount every month because the interest rate is always on the principal amount all the time. For compound interest, the interest rate will be on the total amount. That's why it increases so rapidly. We will practice more questions on this in the next video, just on the financial applications of geometric series and sequences. And I will stop today. That's all. Okay, bye-bye.